We're all getting pretty used to AI that can chat with us, write an email, or even whip up a cool image. But what if AI could actually do things? I mean, really take action? Well, that's exactly where the cutting edge is headed. And today, we're going to break down how you actually build an AI that doesn't just talk the talk, but walks the walk.
So I want you to just think about this for a second. What if your AI could autonomously browse the web, run some code, and actually use software to get a complex project done for you? That's the world of agentic AI. We're talking about a shift from a conversational partner to a genuine functional teammate.
And honestly, the absolute best way to wrap your head around this is with an analogy we're going to keep coming back to. An agentic AI is like a brilliant but totally green new intern. It's got this incredible brain, that's the large language model, but it has no idea how to use the company's software or what the right steps are to finish a project. It needs to learn how to act.
All right, so before we can start training our new intern, we first need to understand what they're actually made of. Let's pop the hood and take a look at the basic anatomy of an AI agent.
Okay, so at the heart of it all is the foundation model. That's its brain, right? The core LLM that does all the thinking. Then you've got a planning module. Think of this as the intern's to-do list, breaking a huge goal down into smaller, bite-sized steps. And this next part is absolutely crucial. It has a toolbox. This is its ability to use external things like a web search, a calculator, or really any kind of API. And finally, it's got a memory module. Basically, its notebook, so it can remember what it's done and what it's learned to give it context for what to do next.
So you have this basic structure, this brilliant but pretty raw intern. The central question for every researcher in the space is actually quite simple. How do you make it better? How do you improve its performance on a task? And it turns out there are really four main philosophies for how to do this.
And this table just frames it perfectly. You've basically got two main levers you can pull. You can either improve the agent itself, that's our intern, or you can improve the tools it uses, its workspace. Then, crossing that, the way you teach it can either be super direct and specific, or it can be more holistic and just focused on the final outcome. This simple grid gives us four totally distinct philosophies: A1, A2, T1, and T2.
So let's dive into that first column, improving the agent itself. This is all about training the intern to be smarter and more skilled, while their desk, their computer, the software, all of that stays exactly the same. So how do we actually train this intern? Well, the first way, A1, is all about teaching the rules, the mechanics. The feedback is super direct. Did you write the code syntax correctly? It's like teaching an intern to fill out a government form. Every single box has to be perfect. The second way, A2, is the complete opposite. It's about teaching strategy. Here the feedback is all about the final result. Did you actually solve the problem? Was the report you wrote any good? We don't really care about the little steps, just the quality of the final outcome.
And we see this A1 philosophy in action with research like Gorilla. This project is focused entirely on one thing: making sure the agent generates perfectly structured, syntactically correct API calls. It's not judging the bigger picture, just the technical correctness of each individual action. The whole goal is flawless, verifiable execution. But then you move over to A2, and this is about mastering the why. You've got systems like Self-Refine, where an agent will try to solve a problem, then literally critique its own work and try again, getting better each time. It's learning from the quality of the final product. TextGrad takes it even further, using the agent's own written critique as a kind of signal, a gradient, to guide its own improvement. The goal here isn't perfect syntax, it's just better problem solving, period.
Okay, so we've covered how to train the intern. But what if we did something different? What if we kept the intern exactly the same? We freeze their brain, so to speak, and instead, we just give them a much better workspace. This brings us to the other side of our framework. And again, we've got two main approaches here. The T1 approach is to just give the agent better off-the-shelf tools. This is like upgrading the entire company from Microsoft Office 2010 to the latest cloud version. The tool is better for everyone, and it has nothing to do with our specific intern. But the T2 approach, that's about building custom tools. It's agent supervised. This is like watching how your intern struggles with a spreadsheet and then creating custom macros just for them based on their unique workflow. And this T1 world is full of these incredible, powerful tools that are built completely independently. Things like Whisper for speech recognition or AlphaFold 2 for predicting protein structures. These are amazing general-purpose tools that any AI agent can just plug into its toolbox. The agent itself doesn't change, but suddenly its capabilities are massively expanded because it has a better tool. Now, T2 is where things get really, really interesting. This is where the tool actually starts to learn from the specific agent it's serving. So, for example, a system called Replug trains a search tool not just to find the best document in general, but to find the document that is most helpful for this specific AI's unique way of reasoning. The tool literally adapts to the agent, creating this personalized, symbiotic system. And that brings us to the real kicker of this whole explainer. Because when researchers started to actually compare these different philosophies head to head, they stumbled onto something that wasn't just a small improvement. It was a fundamental shift in how we should be thinking about building these systems.
They basically set up a competition. In one corner, you have the A2 approach, trying to improve the agent's strategic thinking through that holistic outcome-based feedback. And in the other corner, the T2 approach, keeping the agent's brain frozen and instead training a custom tool that learns how to serve it better. It turns out one of them was just dramatically more effective.
And the result was absolutely stunning. The T2 approach, improving the tool for the agent, was 70 times more data efficient. That means it reached the same level of performance using 70 times less training data than trying to train the agent itself. This isn't just a little better, it's a massive, game-changing difference.
The researchers themselves didn't mince words. They described it as, and I quote, a phase change rather than a marginal improvement. The takeaway here is profound. It might be way, way easier to build a better tool that complements an AI's existing way of thinking than it is to try and fundamentally change its mind. So, with these incredibly powerful and efficient new training methods, these super interns are no longer just experiments in a lab. They are being deployed right now, out in the real world, as a completely new kind of AI workforce.
We're seeing them pop up everywhere. In deep research, agents are automating scientific literature reviews. In software development, they're helping with the entire coding lifecycle. There are even general-purpose agents that can literally watch your screen and use a mouse and keyboard to operate any piece of software you have. And in super specialized fields like drug discovery, you've got teams of agents collaborating to design new medicines. It's happening now. But of course, this incredible power also creates a brand new set of incredibly complex challenges. Because once you have agents and tools that are constantly adapting to one another, you enter this whole new world of weird system dynamics. I mean, first, there's safe adaptation. How do you let an agent learn by trial and error without it accidentally deleting your hard drive or hacking its own reward system to get a good grade? Then there's this idea of coevolution dynamics. How do you avoid what they call a red queen race, where the agent and its tool just get stuck in this endless loop of adapting to each other without ever actually getting better at the real task? And finally, you have the classic stability-plasticity dilemma. How do you build a system that can keep learning new things without completely forgetting the crucial stuff it already knows? And that really leaves us with the big question, doesn't it? As these incredibly capable AI agents and their personalized tools start to evolve together, are we just building better assistants, or are we actually on the verge of creating true partners in problem solving? Or maybe something else entirely? It's a future that is arriving a lot faster than any of us think. Thanks for joining me for this breakdown.